put it like all the way down to your head.
If you leave the top 3 buttons of any button shirt undone, that's a power move. That's just what it is.
You gotta have chest hair though.
Yeah, that's true.
Parks and Rec? You know what Parks and Rec?
Yes.
Ron always wore red. But they have to.
After you got like, yes, you should wear red.
Just have a red suit. First haircut right after that.
Yeah, we're Waltman. And then put on a big white beard.
All right.
If your tie doesn't have the fish that you're actually doing, don't wear a tie.
You're a wrestling unicorn.
All right, so we're gonna spend a little bit of time on this, but this is where we left off with clothing. All right, so just kind of review with this AIC, and our whole goal is to get the lowest AIC value, and in some cases it might be the most negative AIC value because again, as numbers become more negative, that's smaller, right? So with our clothing, we start with full model, and then we go backwards, and we get this equation, I think. What was this? No, that was updated. Scroll up, scroll up, scroll up. I think this is our first one. All right, so backward selection. Started with the full model, we go backwards, scroll down gives the output, and we get to here, right here. Here it is. That's our simplest model that it comes up with, or at least this is where R stops, and it has an AIC of 16,615.97. So I can copy that. I can make the first of my models, all right? And then I kind of jumped and did the forward and say, okay, well, I've got mine, so let's run through the forward. All right, so I start at the null model, and as I add stuff, I get to this point, which, so like a lot of times I look at this and say, well, I can't remember what the other one gave me. So I've got, so I made my mod.simp2, all right, and then I had the mod.simp1. It's like, okay, well, are they the same? If they're the same, then I should get AIC, the same AIC numbers to it. So this gave us 16,609.51. All right. The function to get this value of AIC, because this function, the step function, does things slightly different calculation. You're going to get slightly different numbers. It's how it handles some of the penalties. But you can use extract AIC to get that, and I'm going to say, okay, extract AIC of mod.simp1. Whoops, because I didn't run it. Make these again. Scroll up. Where did I read in clothing? There it is. Let's run this. All right, did that. There. Scroll down, get to here, there's 2. All right. I'm just gonna run this chunk and we can see it. So if they came up with the same model, these lines should be the same. So this right now tells me I don't have the same model. So I go back and say, okay, well I have sex, age, nation, sex, and the sex nation interaction in this model in mod.sim2. What did I get when I worked backwards? Well, when I worked backwards, is that it? Mod full. When I went backwards, it gave me a bunch more. So just looking here, I could see, okay, it's nation size, age, sex, die, nation size, nation sex. I mean, just this right away is saying, yeah, I've got a lot more models here, or a lot more variables. So we've got different AICs, and of course, when I worked forward, my AIC was lower. I must not have found the simplest model yet. So I go through and I start with the most complex term, All right, and again, it is somewhat arbitrary, but you remember that if you have a three-way interaction, then you have to include all of the two-way interactions for those variables inside of it. Just one of our requirements. All right. So the simplest way to go about doing this is just to take this out first and see what happens if we rerun our step procedure, which is what we did. So I updated my model. I reran step 2. All right. And yeah, it simplified it. It removed some more stuff, and I have nation, size, age, sex, die, and nation, sex. Still looks like it might be a little different. So I've got 1610.74. So I'm going to call that mod 3. All right. I'm going to make mod 4, which removes, hold on. We actually did one at a time, I think, and then we went ahead and did both of them all at once. All right. And took our step. And we'll ultimately get to the same AIC, but you can notice when we did this, this was 16,610.74. All right. So that was fairly large. When we updated it, we had a slightly large increase, and then it dropped down to 16,609.51, which incidentally is the same value. So when we got to this point, we're starting to see models that are within 2 units, 2 AIC units, which then kind of says, well, AIC can't really distinguish them. So what do? Well, we could include all of them and talk about all of them, or what I'm advocating is kind of talk about the simplest one. And this simplest one here is going to be this, where we only have one interaction term, and the rest of the terms are main effects. All right, any questions? So we kind of went through here, and now we would have to do, some post-hoc tests. And fortunately, with our size, so I got mod.sim2, that's going to be our simplest. So we can take our simple form and say 2key HSD on the AOV of mod.sim2. All right, and again, just sex nation is our interaction. So we can't do sex and we can't do nation, but we can do age and size. So if we go to age, we just had children and adult. So we know that there's a difference. We can very easily look at means or plots of size as a function of the age to see our trend. And in this case, the adult shirts should be larger width than the children's shirt. And then the other is size. So here's our size from a 2-piece. So we would report these p-values. And we could say, yeah, there's no difference between the medium and large, but small and large and small to medium were significantly different. So that's just the main effect. It kind of seems odd, right? You kind of think you'd expect differences between small and medium and large, but we're not. We didn't see a difference between medium and large. How would we explain that? Talking this relationship here, how do we explain that? Let's do this. What was our variables in here? Width as a function of size. Data is that's our box plots. Right? Right? What's going on? How do you interpret it? I mean, statistically, it says we have a difference between small and the other 2 sizes, and small is going to be the smallest. If we take a look at the averages, right, using the aggregate function, that's what we get. What's going on here? Yeah.
The width of large and medium shirts is the same, the length is the same. That's why.
Okay,
That much
okay.
difference.
All right, did you guys hear that? So, in terms of shirts, we think that as we increase in sizes, we're getting the same proportional increase. Well, what if on these shirts that we selected, small to medium represented the increase in width, but then from medium and large, it's a smaller increase in width, but now starting to get taller. That's a possibility. What else? What's that?
It could have all just been medium.
They could have all been mediums. Yeah, so it's kind of dig in. What about an interaction plot? What can we look at? How about age first? Let's change this. Let's reverse the order. So you got to think big picture. Since we have so many variables. When we did that plot, that main effect, it's saying, yes, sizes were different. And here you get this situation now where when we look at an interaction plot, the interaction was not supposed to be significant. But I bet if we go back and look at those models that are within 2 units, I would bet we have an age and size interaction that's there. That we can't really distinguish whether or not it's important. Look at this one. In the children, medium width is actually slightly higher than the large width. Well, that's kind of interesting. It's kind of interesting. What if we replace it? What if we say, okay, well, let's leave age. Let's do, I think we said nation of origin. Look at that. Maybe whoever's manufacturing the shirts are basing it on maybe their population. So perhaps, between these 3 countries, they've got different standards for what is small, what's medium, what's large. Different standards for what's children and what's adults. All right. So even though our model kind of came out and saying, yeah, there's a difference between small and medium, but no difference between medium and large, the data is much more nuanced. We have to be able to recognize that. So at least for the Tukis, that's what we can look at. And then here, yeah, statistically we're saying there's no difference. But if we go back to some of the other models that are within 2 AICs, maybe then the interpretation starts making a little bit more sense. Now, how do we do sex and nation? This is where we do our subsets. Here it is, interaction effect. All right, so we would basically take men's shirts and look to see it. Is nation still significant? Do women, is nation still significant? It should be. So when we do those post-hoc tests, those 2 keys on those main effects, we get something like this, or pairwise comparisons. Our restricted permutational ANOVA, this is what we get. So basically we're getting differences, except India and Indonesia. We didn't get a difference for the nation and sex. So we do here, let's switch this to you can see your differences here. So yeah, definitely there seems to be something going on where Indian and Indonesia sizes track pretty well, but the main China shirts are much smaller overall. And then, if we did the same thing for sex within nation, that's a little bit easier because we don't have the post-hoc test. If there's a significant difference, then we know men's and women's shirts are different. And just basically in summary, men's shirts are going to be consistently larger than women's shirts. All right.
So for the write-up, we're talking about how the size and age may have been correlated in a different model. Would we talk about that in the write-up? Like in this model, this was correlated, but it wasn't in this one, or?
In the overall write-up for like thesis, you can. So we're going to move on because we're kind of getting to a point. What we've done is kind of introduce the concept of what we're doing, and you're going to have you're going to see a much easier way to come up with your model selection. All right, so we have our option of which information criterion to use. We can use AIC, we can use BIC, which is probably the standard for what you normally see in journals and in research papers. All right. But there is a slight difference between those two, and that is AICs tend to generate a model that's a little too complex, while the BICs usually generate a model that's a little bit too simple. All right, and the reason this happens is tied to power. The power of the test, how powerful is it at actually finding the simplest model, and also how likely is it that we're actually committing a type 1 error. Now, both power and type 1 error rates are related to sample sizes. So if we don't have a large enough sample size, now we start introducing a little bit more error in our model selection. This is where this corrected version of AICs come into play. I think Cody was there to hear Cameron's presentation. She used AICCs. All right, what is that? Well, it's correcting for a small sample size. So if you have a sample size that's small, what it's going to do is try to adjust the AIC to avoid this issue, or at least it hopes to avoid this issue. Now, what's a small sample size? Oh, we have to look at the ratio of how many samples we actually have compared to the number of coefficients in our model. All right, and I can't remember if Cameron actually posted this. If Cameron posted this on the board or not, but in her thesis she did give a table where she listed the number of parameters that she had. All right, and her parameters in like one of her best fit models was 20. All right, so if you looked at the total number of samples that she had after you account for repeated individuals, she does qualify as having this ratio that's less than 40. All right. In our college grad example, we had 36 parameters. You could say, well, hold on, we didn't have that many variables. And I'd say, you're right. We didn't have that many variables. But when you have more than 2 levels, you have an interaction term, and then you have 2 more parameters that code for that categorical variable, that factor. So you very quickly jump up how many of these coefficients we have in our model. So in that college grad example, when we had 900 samples, divided by 36 coefficients, we get 25, that's less than 40. So our proper way should have been to use this AIC. Now, the nice thing is, as our sample size increases, our AICCs will converge with the actual AIC values. So the recommendation that we have is always just go ahead and use AICC, because even if you have enough, it's not going to change your interpretation. But if you actually had a small sample size, AICC is going to be a little bit better. Does R do this? Yeah, R can do this. R can definitely do this. There is one more thing, and it's called a QAIC and QBIC. This is a quasi-AIC or quasi-BIC number. If you have over-dispersion in your data, which is kind of starts to violate some of our assumptions, you can do that. And typically, you would use this for a logistic or mixed effects models. I think I told Cameron to check it out, and I think when we looked at her data, she was good, which is why she stuck with the AICC. Now, that being said, I'm going to introduce you to this glmulti package. All right, this glmulti package is going to be the alternative to STEP. In, I believe, the package description, it says model selection and multimodal inference made easy. And I can't stress that enough. It is made easy. Why? Because it will find all of your models for you and calculate all of the AICs, and then it will return the top set of models. So we don't have to worry about ever hitting one of those localized minimum AIC values. We don't have to worry about updating our models. If we give it the full model and say, here, glmulti, go ahead and figure out what the best model is, it'll do that. All right? Now, this thing is a complete wrapper. All right? So there's a lot of things that it can do. And it's going to do these things based on how it detects the model that we give it. All right? So we can fit linear models, which is what we're going to do. We can fit generalized linear models. It can fit linear mixed effects models. It can fit generalized linear mixed effects models. This is what Cameron was doing with her multinomial logistic regression. So she can do this if she wants. The alternative is this MUmin package, which would also kind of do the same function. It would take our full model and create all possible combinations and then report only the best models. All right. The downside of this MUmin is that it doesn't pay attention to those interaction terms. And we have that very strict rule that if we have an interaction term, then we have to include the main effects with it. If we have a three-way interaction, then we not only need the main effects, but we have to have all of the two-way interactions included in it as well. MUmin doesn't abide by that rule. All right, so if we use MUmin, you have to go back and make sure that any of your main effect or any of your interaction terms also have the subsets below it. glmulti, make sure that that is true. And that's why we're going to use glmulti. The downside of this, we have a maximum of 32 factors and 32 covariates, and a maximum of 128 interactions in each category. Is that going to be a huge problem? Probably not for us. All right? So how do we do it? How do we use the glmulti? First, you're going to have to load the package. All right, if you're on your own personal computer, you're going to need to install this package. Then this is going to be basically a two-step or three-step process. All right, the first process is actually create the output. You're going to let glmulti do its thing. All right, we're going to let it do its thing, and we're going to save whatever it's doing. And then what we're going to do is call the summary output, and that'll say, okay, this is what I found. We're asking, hey, what did you find? Give me a summary of it. And it's going to tell you everything in that summary. If we want, we can look at a weight table of that output, and because it's going to show all the models tested and their AIC. So it's going to generate all of these summaries for us. So how do we go about producing this output? Well, it's actually fairly simple. We're going to give it the formula. We're going to give it the full formula. We're going to give it data where we find those variables. All right. If we wanted to, we could exclude the vector of terms. So we can kind of exclude an interaction term, perhaps, if we didn't want to include it. All right. Have I ever done the exclude? No, not really. But you can force it. Say, I want you to leave this out. And we also picked critical value, our selection criterion, which we'll use AICC by default now. And then we'll save it as the output. We will also have, once we have that output, then we can view the summary, the weight table, and we can also do a plot of the output. And the plot is going to give us model average importance of terms. It kind of gives us a check of each of the variables in our data set to say, yeah, we should probably include this, or no, we should probably not. As I put up here, and we'll talk about it, general idea is that if that term appears in 80% or more of our best fit models, then it's probably an important term. It doesn't always have to be, but it's probably an important term and we should probably keep it. One caution, if we have continuous variables as independent variables, so let's say we had size as a covariate, our interpretation of the weight tables and the reliability of the models will become a lot more complicated. Because right now, this is kind of really about factors. So college, grad. All right, so the question is, we already came up with the simplest model using the step function. And you saw how we did that. Started at complex, worked backwards, started at the null, worked forward, right? Question is, does glmulti give us that same simplified model or simplest model. So what I want you to do is using this code here, use the college grad data set, generate or figure out, see what glmulti tells us is the simplest function. Play around, see what summary of the output gives us, see what weight table gives us, see what plot gives us. All right, and then go back and look at what our college grad example best fit our simplest model actually was. Don't forget, glmulti needs to be loaded.
I'm having trouble loading glmulti. It's asking for our Java, and our Java won't load either.
Yeah.
And then, I just ran mine at work. Yeah.
So on this computer, I had to install hold on. Yeah, I had to install glmulti, and then it was loaded. Let's see what yours is. The max might be a little. Did yours work? Okay, so you try to install glmulti.
Yep.
Well, this is how did you install it? Hit install, and then glmulti.
Got it. Now we're rocking, baby.
I installed it so far. I guess maybe I also need to install our Java.
Yeah. Now let's try that, and if it says it still needs
Yeah, so that's
R Java. Okay, so see if you can install R Java.
What is the full hours of the salary? Circle back on that.
Yeah, JVM.
No.
Yeah, I don't know what we're
Let me look that up. You may have to install the Java runtime through your package manager. That is a Mac. What version?
Maybe.
Okay.
You're on three.
Oh, iOS.
What's that?
iOS something.
14?
Are we replacing the AIC?
No, it's AICC. The criterion, selection criterion is going to be the AICC.
Yeah,
That's going on.
10.15.7.
10.15.7 are Java runtime.
I was like, 7? You're so weird.
I know, it's kind of topic,
Did you do it, Cody?
I'm trying, and it said no. Yeah, that's not what it's going. It's just gonna be summary. Summary.
Get your model around.
I'm trying. So I did something.
No. We just get rid of the excluded.
Yep, yeah, ignore the excluded.
I've been waiting on that.
You put balance equals?
Oh. Sure.
Oh, then you have to go right up top.
Evaluating model.
All right.
Well, it's gotta be when you
Here.
have excluded rules like a flow.
Your terminal window. So in R, you should be able to go down to terminal like this. So I clicked on my terminal here.
Yep.
All right. You should be able to type this Java dash space and then dash version.
Okay.
Java space version.
Yeah. So it should give us a version of Java.
Put LM.
Install this JD.
I think I'm gonna make a very small formula and then just include that.
Yeah.
Oh, it's good to know on the same page.
Let's see how that works. Yeah, so it says if it's not installed, it should prompt you to install it. All right. And And then there's also instructions on how to manually install it. But hopefully that installs it.
I'm not getting you.
Oh, it's probably in the background. So I think that was your system terminal. So something that was like your notifications or something like that. Is it downloading a package or installing a package?
Okay, mine seems to not like the AICC in here.
What is it? What is it? What do you put?
I've got glmulti and then my formula. And then they equals hotchkiss and then curriculum, they have all, but it's got the red squigglies around the ICC.
Do you have, did you put AIC in there?
No, I did just like the ad. I just copied and pasted it from the PowerPoint. So, oh, maybe it doesn't like the.
Do you wanna join?
I tried putting a full model, like, to get it on there.
You look at the PowerPoint. Scroll down the PowerPoint.
Okay, well, she included you, so I just responded.
Yeah, I tried that too.
I just told her, I told
Hey, take your data.
Oh, sorry, I can see everyone. I was alone, you know.
Mine's just cannot find glmulti, gathered installed.
It's not even.
Oh.
You get through?
I didn't actually, because you guys didn't actually do that. So
I wanna go with the camera and I just don't wanna go with the stage.
I didn't.
It's weird if I go.
You're dear.
I didn't.
How'd you do yours?
They have milkshakes, they have
I
really.
used
I might go through.
grad.full and mod.full.
You can, they
And
also
then
have
I
the
didn't put the data frame. So mine says output, left arrow, glmulti, open parentheses, grad.full, comma.
This is what you said. You want to install it. This is what you should pop.
I ran that. Yeah.
Yeah, I ran just a picture model.
So now it's whatever you are.
I think she is. It's fine.
Yeah, I don't think you need to do it in the library or a job. I think you can just do that and say glmulti. And I think
I didn't even put a simple model, I literally just put the full model.
Yeah, it still gets everything.
Yeah.
Yeah,
we've seen that. I've seen
I
it.
could honestly go back there.
And I was like,
Yeah, did you load it?
Yeah, my truck ran it twice. We just drove towards it. Got the new tires on them. They're driving a little bit of a little better.
glmulti.
Yeah. I think it's getting old. I think we got the same. Heated leg.
glmulti.
That out of the way.
Oops, hold on. Did you glmulti? Right?
Doing this for college.
yeah.
I'm sorry.
I just copied it.
So.
Cannot find JVM. Aha. The same thing. That didn't actually load.
I saw.
Okay. So we're gonna use this terminal. Type in Java space dash version. No space
Yeah.
more info.
But it's you're gonna build model plus when you get it.
I think now
Maybe bring it over there.
Yeah.
So maybe you guys like, oh,
You want your Mac logos installed.
Text homework.
Finish this, go ahead and click on that file. Should extract it.
Did that, Tomorrow's the best day to do homework. Honestly, you have anything after morning? Are you free on?
Do you ever read
Let's get over it.
I was gonna say, if you touch the paper, I'm about to do that. I know, I saw it. I'm excited. I'm excited.
It's not overly complicated. They might have won the award for best paper.
They got that one?
Yes, not overly
I mean, they
complicated.
do that really quick.
Now go back to your R and then click go back.
Yeah.
Now run your GL.
I got the exact same thing. Oh,
All right. So if you have a Mac, you probably have to install the Java. And just so it's up here so everyone can see, if you have a Mac, and I don't know if anyone's at home, when you get to your terminal, yours is going to be a little bit different. This is a Windows terminal, command prompt. If you did Java -version, I don't even know this will work on Windows. Yep, it'll, like if Java's installed, if the runtime environment's installed, it should give you the version. All right. In the Macs, it was saying no Java version installed. You know, requesting installation. It pops open a window and says you want to install it. Well, the first time you clicked OK, it didn't seem like anything happened. So what I suggested doing was doing the more information that took you to Oracle's website. You download the JDK, click on that, then you have to scroll down to the bottom to pick your operating system, which would have been the Mac OS. You download that file, that installation file, you extract it, click on the package, it'll automatically install it. And once it installs, then your glmulti will work. All right. On Linux, it's a little bit, basically need the same thing. You need a Java runtime. So I have glmulti loaded. All right, so I'm going to do my output, glmulti, and oh, we're doing college grad. Didn't even download it. College grad. Copy that. All right, GL. Salary is a function of school times state times school times major times time to grad. Our data set is college grad, and then our criteria, selection criteria, is going to use the AICC. And when I run that, you're going to see that that creates these outputs. So what this is doing is basically, it's not going to create every possible combination. All right, it's not going to create every possible combination. What it's going to do is try to do it iteratively. All right, try to add and subtract some stuff to minimize how many models it actually has to find. What we're looking for is this. It's for it to be completed. And there's only been a few times where it doesn't get that. It'll say something like, no simple model is found, or something like that, or it didn't converge, or something like that. Can't really remember what it was, but it says after 50 models of testing, I came up with this best model. This was the AIC value. All right, but then if I kept going and kept trying to find another model, after 100 models, I found this as the simplest model, and this was the AIC, which you can see it was basically the same. All right, so it said, okay, after these, I did 50 and I did 100. I came up with basically the same. I came up with the same model, so this must be the simplest model. All right, we can always increase glmulti. So if you just looked at the documentation, glmulti, you will see that we have options here that we could say, hey, let's increase what we're doing. So, you know, if I wanted to, I could increase our population size. I could change some of our selection criteria. I wouldn't do that unless you're running into convergence problems where it can't find the simplest model. So this is good. This is what we want. All right, this is kind of showing you, model support, and you're getting basically a couple models that are actually pretty good support, but we don't know what those are. So what we can do now is to look at the summary. And we've created our output, so I'm going to create the summary of the output. And what it does is says, okay, well, we ran this analysis, came up with the best AIC value is that. It came up with all the different AIC values, all the different weights, gave us a best fit model. That's not necessarily that great, but it gives us information that we can use that when we look at our weight table, this is going to give us a table of all of our models ranked from best to worst. From best to worst. And this one, actually, let's see if I can.
So,
I'm going to do this. I'm going to go down in the console window. Because what it is, the table's too big. That's the issue. The table is too big. It is. It is. So I guess we'll, instead of that, we'll be forced to look at this. So we know that it is going from best to worst. All right, so the simplest model that it came up with is this top one. What's the AIC value? This. So 6748.835. The next best is 6750. Now I think that's a different AIC than what we did with the step function. And it's because we used AICC. We used a small sample correction factor. All right, so are we within 2? Barely, barely. All right, what about that third best model? Now at this point, we're beyond 2, more than 2 units. So really, the only ones we have to look at are these 2. So what are those 2? I'm gonna go back to here. It's school major time to graduation and time to graduation major interaction, and then we have that major school interaction again. Kind of same thing we found. We said we had the AICs, they were close, but we went with the simpler one. I can't remember. I think this was the simplest. We didn't have to worry about this major school. What about the plot? What did the plot give us? Oops. Let's see. Type S. This gives us model averaging. So it's going to take all of the models that you came up with and kind of ask the question, well, how many models is each of these variables in? And it'll include interaction terms, but it's not going to include every single one because you had a bunch of them that appeared in maybe only one model or 2 models. All right, so what we're looking for is 80%. That's our cutoff. Any variable that occurs in more than 80% is probably important enough to include. Which one? Oh, type S. Yeah, it's on the PowerPoint too. All right, so it's doing model averaging. It's looking at, okay, out of all of these, how important is it? So you can see that major school, it was in that second best model, but it actually, that occurred in fewer, this interaction term occurred in fewer overall models than the main effective state. So that right there tells me, okay, probably major school isn't important. So let's focus our efforts on interpreting these top 4 terms. All right. So I just did a side-by-side to kind of show you the difference. As I said, when you have a large sample size, the AICC will converge with the AICs. They're both pretty similar. They're both pretty similar. Pretty good. how do you present it? Here's one way. And Cameron did report it. So you had the table of models, right? That's what the weight table gave us. The table gave us AIC values or AICC values. So what you do is make a table and you list what your variables are. Now, preferably, I say use some font that lines up all of the terms. So that way you can clearly see what terms are missing from various models. So I made sure these top 4 lined up, and then you can see I added major school, I added state, I added time.grad school, and I added these because these were the top 4 models. But very quickly, you can see that we went above that 2% or that 2 unit cutoff. Well, I could do it manually by subtracting our values, or go ahead and add in a second column that says, I want to know how different our AICC value is compared to our best fit model. And this tells me, once I hit 2, that's not included. It's not analyzed. There's really no reason to include both the AICCs and the regular AICs. Just pick one, go with it. And recommendations to use the AICC for the small sample size correction. That's going to be our recommendation. All right, and we showed you the plot, kind of that major school, should we really include it? Yeah, it occurs in maybe 33% of all of our models that were created. That's not enough. It's probably not important. All right, so conclusions stayed the same as if we ran the step. We got the same answer. However, the glmulti, whole lot easier, right?
Yes.
Whole lot easier. So, go ahead and try the clothing. You know, the mess that we had, the difficulty, use glmulti on that, and I think you're gonna see that, wow, this is the way to go.
In the most harmonious model, would it be like salary time.grad plus school plus major, or would it be times school times major in the code?
For what? For this?
Plus, okay, yep.
Yeah, so these were the simpler models.
Okay.
And I think that's listed on our table too, on our weight table. I think part of the issue is I've got it zoomed in, so it's larger. You may be able to actually see the weights. I'll show you a trick.
Are you supposed to get like 15 plots back after this?
What do you mean 15 plots?
More than that, actually. I ran glmulti on the full clothing model.
Yep.
You got a lot too?
Yeah, I got a lot.
So in a lot of ways, what it's doing is starting at different points and doing the step function to figure out if I start at different points, do I come up with the same simplest answer? And that's kind of a whole lot better than trying to make all possible combinations.
So it just runs X amount of models until it gets the best fit model completed. There's no set number instead of that.
Nope. Hopefully it converges.
What's your function of one?
Yeah, what's up with that? Why is it 1 plus school major time grad or 1 plus whatever?
In what?
Whenever it tells you your best model, like this says width, the function of 1 plus.
No, oh, the 1 is the intercept. It's the interceptor.
Okay. Well, I'm not getting anything. That sounds like a huge problem. Like, we're trying to figure out the easy one. Don't you win? Don't you win?
How do we decide which model to feed into the
Yeah, full model.
model?
Yeah, just get the full model.
Is that what we did with college grads?
Yep, should. Let me add.
Without any of the interaction?
Yeah, no, we included all of the interactions. Let me see if I get the same thing. Say output 2. Here we go.
Why we never learned that hard way, I don't know. Probably,
That way we can be great.
probably for understanding, but, you know. As a millennial. My job.
I demand satisfaction.
My job to complain that it was like.
We didn't use the full model, we used the most parsimonious, the full model found. Yep.
You just use your full model.
Everything.
Everything.
glmulti is gonna find your simplest model.
Oh, gosh, so I did that.
So are you nervous?
So you could use just the fully additive model. Well, I don't know. I think that would help you.
Isn't strength
Oh,
always
when
your
you multiply,
Yeah, it'll do everything.
then that's all
Yeah. So it does look like when I did all of the additive model, that I came up with the same tables.
Yeah, well, the thing about that thing is, we're not clean, we're with your size or something else. I can be like, I like your writing style.
All right, so I ranked both of them just to kind of demonstrate. So I just always make it a habit of doing the full model because you make the full model in order to check your assumption. So if you just use the same full model and start, you will come up with the same answers as if you had this, but perhaps we didn't want to include that 5-way interaction. That's where the exclude can come into play, if we wanted to exclude. So with the output, what I could do is use that 1 to 10 in brackets, subscript notation to say only return the top 10 models. And our table, yours is probably all on the same line, right? Or is yours zoomed in too?
For what?
Gotcha.
The table?
Yeah.
Yeah, there's a lot of, I have like 10 pages.
Yeah.
100 tables.
So what we're interested in is we're looking at, oops, hold on, I didn't do the AICC.
Okay, yeah, I didn't even check that. You can click over. See that, see. That makes sense.
Again. It's running.
There's like multiple things we've done in this class that would have made
undergrad stats, like 10 times a year.
right.
That just never got talked about in undergrad stats.
What?
Never got talked about.
What?
I'm worried.
Like what?
I'm worried. They show you, oh, wait, that's the easy way after you've been suffering. Appreciate that easy way.
All right, I got a huge one. Here's that console output. So you can see, man, when this thing ran, look at how many models it made. All right? Because again, what it's doing is trying to give different starting points to reduce how many different combinations of models it needs to get. And what it's hoping to find is that one simplest model. And if it can find that simplest model repeatedly with a couple of different starting points, then that must be the simplest model itself. So on this output, this was, there it is. Yeah, it went 1,500 models. So exhaustive screening of candidate set, fitting, and it's finding all these different ones, and you can see that it found one model here, but then it found a different model, and now at that point it's starting to find the same model repeatedly. But because we have such a large data set, it's going to keep going until it feels confident that it's finding it. And that's where you can read the PDF that describes this package, what they're doing, and the selection criteria. So we can make it more stringent. We can make it a little bit more liberal in how it selects the best models. But I think using the default is sufficient. We can look at the weight table, and sometimes the weight table is just absolutely huge. So what you can do is do a subset and say, just give me the first 10 rows. So 1:10, comma, and then nothing after that. So it says, give me the first 10 rows, but give me all of the columns that are there. So that way I can view only these first 10, because those are probably the only ones that you're interested in. So the AICs, hold on, let me run that again. There it is. There it is. They're all on the same. Got them. It's reporting the AICCs, and you can see that going from that first model to the second model is just under 2, right? And you can see that some of these, we don't hit 2 until we get to here, 7. So we've got these 6 models to report on, and probably not just the 6. I'd probably go up to 8 or 10 just to kind of demonstrate that the difference to that best fit model is all going to be within 2 up to a point, and then you start seeing, you know, it's more than 2, upwards of 3. AICCs, yep, 1 to 3.
Should
All right.
we also be looking at output 2?
What's that?
Should we also be looking at output 2?
No, output 2 was just my check. So if you did the full multiplication or just all addition, they come up with the same.
They show the same number.
Yep, it comes up with this exact same. So this was output 2. We come up with the exact same models. So it'll automatically add the interaction service too, which is nice. All right, what about the plot? So plot of the output, type S. And this is, I think, where it really kind of shows which terms are probably the most important. So nation, size, age, sex, and this nation-sex interaction, they all appeared in over 80% of our models. And in fact, they appeared in 100% of our models. Those are probably very important terms, all contributing to the width of those shirts. The next one is die, and that actually appears in 70% of our models. That one might have some effect, all right? But then you look at the rest of these interactions, those other ones that were in like that second, third, fourth best model, and they're appearing in less than 50%. In this case, probably 40%, 40% or less. So those are probably not variables that are significantly important, or at least they don't predict width. So what's our best fit model? Based on all this information, probably back up to this: nation, sex, age, sex, and sex nation. That's probably what I'm going to report. Right? Exactly, yeah. So, any questions on here? We're gonna end with this. Mu-min. So this is another package that does the same thing. Mu-min has a function called dredge, which is basically doing the exact same thing. We're trying to data mine to figure out what our best model is. Right? That's the focus. The downside is that it does allow you to compare models that have interaction terms but lack those main effects. So as I said, if we have that y is a function of a plus b, I'm going to say this, plus c to d, mu-min allows us to compare this model to this model. All right? But the problem is that with this interaction term, we're missing the main effects. All right? glmulti won't ever let that happen. If it adds this interaction term, it's going to make sure that C and D are included in that model. All right? And now we can make the comparison. So for that reason, I actually prefer the glmulti over the mu-min package. But you can come up with the same answers as long as you remember our rules about those interactions. If an interaction term is in there, we have to include all of the main effects and the sub-interaction terms as well. So it's just one of those things you have to know. glmulti corrects it for us, mu-min does not. All right. Any questions? One other small point. I'm going to go up to mod sim. Let me just make something new here. Whoops. Mod sim 2 maybe? All right. Mod sim 2. That was one of our best fit models, right? I said when we do extract AIC, it gives us the AIC that it calculates. There's another function called AIC that will also give us an AIC value. But note the difference. Yep, note the difference. 16609.51 versus 26827.87.
What are the two numbers on top?
I believe that's a number of coefficients, that k parameter. So what's the difference between these? In order to find that, we would have to look up the help file. All right, and as we scroll down, you get to this spot here, that paragraph. Different constants have conventionally been used for different purposes, and so extract AIC and AIC may give different values, and they will for models of class Ln. All right, and there's caution about using these two methods. So if I go to extract AIC, it lists the criterion methods. Now the criterion methods are there. Is this part. The additive constant is a little bit different with the extract AIC from with the regular AIC. That's the reason for the difference in the numbers. Is it going to change which simplest model we find? It doesn't. It doesn't. So the word of caution here isn't necessarily, oh, be careful, you're going to find a different answer. No, it's you have to be specific on what you use in your methods. All right, if you're going to do this by hand, are you using the step function, perhaps? Or are you going to do it yourself and use AIC or extract AIC. You're going to get slightly different numbers. You have to let the readers know, because if someone grabs your data and tries to repeat it, maybe they do something different. Maybe they use glmulti, or maybe they use the step function, or maybe they use some other criterion method to get that. All right, so there's just some different ways to calculate these AIC, the actual numeric values. But the relationships, which ones are the smallest values, that's not going to be affected. Or it's not affected by it. All right? Questions? So, I think Cameron is going to be using this glmulti. Now you guys are familiar and feel comfortable with it. Maybe there's some bribery to get, like a free coffee, to help her out, some of her models, right? Just a hint there. But no, if you're going to get to this and you need more help, come find me. We'll help out, especially if there's issues with finding the simplest model. As I said, I only had that happen once with the data set. All right, so I did post another practice problem. It's on Blackboard. It's on our lecture page.
Oh, perfect.
Yeah, bird food. Yep, bird food. So save the link as, get it to my file, and open it up in R, and then I'll describe what it's supposed to represent. All right, it's saved. Go in R. All right. So, oops, hold on. So you download it. All right, so here is the basis. And this is to give you a little bit more practice, doing the AIC for simplification. All right, so you went out, you've got a bird feeder, and what you're interested in is the number of sunflower seeds that get consumed by birds when they visit. All right, you started recording it, and you broke it down by season: spring, summer, fall, and winter. You did it maybe over a 2 or 3 week time span in each season. So you recorded the species. You saw doves, you saw starlings, you saw cardinals that come through. You probably saw some other ones, but these are the most common ones that came and gave you a large enough sample size. So you were a master birder and could sex them from 10 feet and 20 feet away.
But you didn't know what kind of dove it was?
It was a generic pigeon. Pigeon/dove that poops on cars all the time. Yeah. Dove, cardinal, starling, right? All right. So you had the sex, and then with the food. So you go out and buy bird food or bird seed. You see it's kind of mixed in with different stuff. So you have your seed, your sunflower seeds, but then you either mixed it with millet or you had mixed with some corn, cracked corn in there, and then what you did was, again, your super sharp eyes, you were able to actually count how many seeds each bird consumed as they visited. It's fantastic. So what we're interested in is, did these individuals, or which of these terms, 4 independent variables, influence the number of sunflower seeds that were consumed during their visits? All right, so at this point, check your assumptions, find the simplest model. Yeah, let's do that. Check your assumptions, find the simplest model.
What's the extra level?
The extra food that was added. So sunflower seeds, and then what else? Either millet or corn. All right, so what we can do is you can practice that, and we can talk about it on Wednesday.
That's a homework.
What's that? No, that's not the homework. The homework is posted. So I got that posted up. 3-way plus and 3-way plus ANOVA. So part 1, part 2. All right. Part 1 is basically, I believe, the assumptions might have been met. So what I'm going to ask you to do is kind of work through that for Wednesday. So if you have questions, if you run into errors, you can bring those questions on Wednesday. And then for next Monday, I want you to work through this part 2, which is we basically violated assumptions, or under the idea that we did violate assumptions. All right. And in some cases, maybe the assumptions are met, but we're just working with too large a data set to do things classically by looking at ANOVA tables and manually removing terms. All right. Our goal, again, if you have questions on how to do this stuff, bring those questions to class. All right, and we'll address them. The plan next week is to have our next exam, so kind of have it go live, possibly. We'll see how Wednesday goes, but it's to give you, this is kind of like the prequel to our ANOVA, because what we're going to be doing then now is to introduce continuous variables, or what we call covariates. So like in this whole bird, season, species, sex, etc. One of those covariates could be, distance from, how distance from the observer, right? So maybe how long the bird actually fed was based on, or it was correlated to, coverage or openness. All right, how do we include that? Or maybe a covariate is time spent there, with the idea that the longer you've been there, the more of these sunflower seeds you're going to consume. How do we include that sort of thing into the models? How do we simplify it? So we'll start small with just 2 continuous variables, and then we'll quickly add additional ones, and you'll see that the analysis is basically the same as what we've learned up to this point. It's just the interpretation of a continuous variable that changes. All right?
Or just be on.
Probably not. It'll probably be the following week.
Not next week. The week after?
Yeah, probably the week after. So that gives us time. If we have questions, we could answer them next week. And then, yeah, it would go live. Like the take-home part would probably go live on maybe Friday. And then it'll be due like that Wednesday. And then we'll probably do the Blackboard like Tuesday or Wednesday or something like that.
Is it the ANOVA test or is it, what is it, what are we starting on for this?
Yeah, 2-way plus.
2-way plus, okay.
2-way plus. And that includes assumptions met, assumptions violated, post-hoc tests, restricted permutational ANOVAs. I'm going to make sure I have a 3-way interaction. So subsets of subsets of subsets.
So many subsets. Half page long.
Have you heard anything about our meeting next week?
Not yet.
I haven't got the emails or anything.
Did you register?
Yeah. I was like, I didn't